Hello everyone, myself Vinay Kumar M. So I am actually pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So I am actually teaching 8th standard mathematics subject. So in that I have covered 3 chapters in this particular 8th standard mathematics subject. So now I will be teaching 4th chapter, that is actually data handling. So in data handling, you will be having 2 parts. So first part will be containing explanation related to graphs and exercise 4.1, and in part 2 video I will be actually explaining probability and exercise 4.2. So please watch both the videos, like both the parts, then you can easily understand this chapter 4 which is there in this 8th standard mathematics. So any information, if there is a form of expressing that particular information, so that if we just look at that particular form, we should be able to collect all the information which is actually required. So to know a particular information, then graphical representation will be easy way of expressing that particular information. So for example, you have like 2 different informations or 2 different physical quantities which you have to relate each other. Then you can actually easily draw a graph and you can actually compare those physical quantities, and you can actually express the information which is there in that particular graph. So for example, if we consider a set of students who have passed and who have failed in a particular exam, so or different subjects, then we can take number of students. So let us say number of students, like so many number of students are there in a particular classroom. So there is some certain subjects which they are giving exams for. So let's say science is one subject, maths is other subject, English is the another subject. So let us take 3 subjects. How many number of students has passed in a particular examination? So I'll write number of students who have passed in science is actually 30, in maths is 40, and in English it is like 50. So for example, if we have total number of students as 60, then 30 will be passed in science, 40 will be passed in maths, 50 will be passed in English. So here, just by looking at this particular raw data, so understanding this particular information in a graphical representation will be very much easy. For example, in a graph, we will always have 2 lines. One is horizontal line and one is vertical line. So horizontal line is actually known as x-axis and vertical line is actually known as y-axis. So you have 2 informations which is there in this particular data. Like for example, this can be known as data because you have 40, 30, 40, 50 pass in science, maths and English. So that shows this particular subjects is one particular data set and number of students who are getting passed in that particular subject is another data set. So now you can easily express this particular data in a graph. For example, we have number of students passed, so that I will take on y-axis. So number of students will be there on y-axis, and one information like one data, one particular data will be like subjects will be on x-axis. So for example, let's say this is science, and let's say this is maths, and let's say this is English. So now we can easily see there is number of students on y-axis. We can actually scale this particular y-axis. So scaling of an axis represents that. So one particular unit on a graph sheet will be equal to a certain number. For example, here we have to see how many numbers we have to reach till. So we have 30, 40, 50 and total number of students are 60 in a class. So here in this particular data, the maximum number which we have is 50. And the minimum number which we have is 30. So this 30 and 50, the minimum number and the maximum number, the minimum data and the maximum data should be taken on the axis. So in whichever axis you are actually scaling the given data, you should actually consider the minimum data point and the maximum data point. So here it is 30 and 50. So now on this y-axis, you should actually start from 20, because if you start from 20, it will actually include 30 to 50, because now if one particular unit, so this is actually known as 1 unit, so if that 1 unit is equal to 20 students, then this second unit will be equal to another 20 students. So the first unit and second unit. So total it will be 40 units. So in this second place you will be writing like in this second position. So in this second unit you are writing 40. So third unit will be 60. Next fourth unit will be 80 because here one unit is actually 20 students. So one unit on y axis is 20 students. So similarly you go on writing the data points. So in this you can clearly see we have actually started from 0 and we have went till 80. So from 0 to 80 it contains 30, it contains 40, it contains 50. So that actually shows how we are actually scaling a graph, how we are actually scaling an axis. So on a particular axis we are actually dividing the units like one unit into a certain constant data. For example, here 20 is actually constant. So first unit is 20, second is 40, third is 60, fourth is 80. So always you should start from 0 and go up to wherever it is required for your data to be fit in. Because here I have maximum till 50. So 50 till 50 I should actually fit that particular data on that particular y-axis. So I have started from 0 and one unit I have given as 20. So second unit will be 40, third will be 60, fourth will be 80. So on x-axis also one particular unit is science, the second unit I am actually assigning as maths and third unit I am actually assigning it as English. So now I can easily draw a graph. We have 30 students passing in science subject. So this is a particular data. So 30 will be in between 40 and 20. So the half unit which is there in between 20 and 40 will account for your 30. So this particular point is actually 30. So from here to here you just draw a perpendicular line and you draw another perpendicular line from this science subject. So the intersection of these two perpendicular lines will be your first point, where this particular point is actually conveying you 30 number of students are passed in science subject. Similarly, now you just draw a perpendicular line from 40 because 40 students are actually passed in mathematics. So if you draw a perpendicular line from 40 and if you actually draw a perpendicular line from this mathematics which you have assigned on x-axis, so the meeting point of these two perpendicular lines will be the data point which will explain how many number of students are passed in mathematics subject. Similarly for English also you can take. So now you want 50. So the intermediate point between 40 and 60, like the exact midpoint of 40 and 60 will be 50. So this particular point, the half unit on that particular y-axis which is in between 40 and 60 will account for your 50. So you just draw a perpendicular line from this 50 and also you can draw this perpendicular line from English subject and this will be your third point. Here you can clearly see that number of pass in science subject is less. That's why this point is actually below these 2 points. But mathematics, pass percentage in mathematics or number of students who have got passed in mathematics is in between science and in English. Similarly, in English, maximum number of students have got passed. So like this, if you just look at a graph, you can actually extract multiple information from that graph. So now you can easily say how many students are passed in science, how many students are passed in maths, how many students are passed in English. So where does mathematics lie in between science and English? How many students, like which subject has minimum number of students passing and which subject has maximum number of students getting passed? So like this, so many information which is actually embedded in this particular graph you can actually extract. I have given so many number of students passed in a particular subjects. So just by looking at this data, you extracting information will be difficult. So if I plot the same data in a particular graphical representation, then you can easily note down like what and all information are actually there in that particular graph. So this is how you should actually analyze a particular graph. So this was the explanation of graph. Now let me discuss 3 types of graph which you will be learning in this particular chapter. So one is pictograph. The first one is pictograph. So you will just represent pictorially a particular information. For example, we have 20 or let's say we have 25 cricket balls. So let's say we have 25 cricket balls. Now you have to express this particular data 25 as a pictorial graph. You can actually draw the picture of a ball and you can actually assign one picture of that particular ball will be equal to 10. For example, let's say this particular picture is actually a ball, like it represents a cricket ball. Let's say this particular picture. So one such picture of a cricket ball will be accounting for 10 cricket balls. Here the data given is 25. That means you should actually draw 2.5 pictures of this particular ball so that it will account for 25. So let's say this 25 I can actually express in the form of pictorial graph like this. So one particular ball will account for 10 balls. So other ball will account for another 10 balls, and half the image of a ball will be accounting for, let's say, another 5 balls. So by looking at this particular graph and by looking at this particular number for this one particular image, you can actually get information of how many balls are actually present. For example, by looking at this picture, you can say if one image of this particular cricket ball is accounting for 10 balls and we have this particular graph, then that shows 10 plus 10 plus 5. So total 25 balls are there. So where one ball is accounting, like one image of a cricket ball is accounting for 10 balls. So 2.5 such pictures of a cricket ball will actually account for 25 balls. Because here you cannot write the image of all 25 balls. So you will actually assign a number for one particular ball, that is 10. So one image of a cricket ball will be 10. So similarly, how many images of cricket ball you write, you will just multiply that with this particular 10. So you will get the total number of cricket balls which is there. So this is how you should actually use pictograph to represent a particular single data. So coming to the second type of graph which you will be learning in this particular chapter is bar graph. You actually draw a particular rectangular shaped bar on x-axis according to the corresponding y-axis values. So I'll explain how it is by an example. So let's say there is a school. So number of students who are getting admitted to this particular school is given like this. So let's take year. So in the academic year 2005 to 2006, actually 20 students joined this particular school. Similarly, in the academic year 2006 and 7, let's say 30 students joined this particular school. So in the academic year 2007 to 2008, let's say 50 students actually joined this particular school. So how we will represent this particular data using bar graph? So let's see. So here you have two data sets. One is number of students and one is year in which those particular number of students have joined this particular school. So these two data are there, and when you have two data sets, you can actually draw x and y axis, and you can take one data set on y axis and one data set on x axis, and you can make a comparison between those two data sets. So now we have to make comparison between number of students and academic years. So let us take academic years on x-axis. Always remember, horizontal axis will be x-axis and vertical axis will be y-axis. So now I have to scale y-axis. Now I am taking number of students on y-axis and I am taking academic years on x-axis. So now you have to scale your y-axis, because on y-axis you should actually take number of students and that particular y-axis should contain up to 50. So the maximum data point available here is 50 and minimum data point is 20. So at least 20 and 50 should be involved while scaling your axis, like your y-axis. So now similarly, as I explained before, I will take 1 unit on x-axis as 20. So this is actually 0th point and this is actually 1 unit on y-axis. So 1 unit on y-axis is actually equal to 20. So the second unit will also be equal to 20. So 1 plus the first unit plus second unit will be 20 plus 20, that is 40. So at the end of second unit it will be 40. At the end of third unit it will be 60. So we will not go beyond 60 because maximum data point is just 50. So I am stopping at 60. So we have from 0 to 60. So we have values starting from 0 up to 60. So that means this particular range is actually containing 20, 30 and 50. So all your data sets will be there. All your data points will be there in this particular range. So like that you should actually scale your axis. Now I have scaled in between 0 to 60 where I have given 1 unit equal to 20 number of students. So let us take on y-axis the first particular unit will be 2005 to 2006. So this is your first unit. So in the second unit you will be taking 2006 to 2007. On third unit you will be taking 2007 to 2008. So this is actually academic years which is written on x-axis. So now you can easily draw a rectangular bar graph on this particular x-axis. So you should first note at which particular point this particular, so you should note how much will be the height of that particular bar graph, because here number of students joined in 2005 to 2006 is 20. So the height of your rectangular bar graph should be there up to this 20 mark, because it should not exceed that 20, because only 20 students have got admitted in 2005 and 6. So you should write a rectangular bar graph on this particular 2005 to 2006, and this particular rectangular bar graph should actually stop at 20. So the height of that particular bar graph should stop at 20. Similarly, in 2006 and 7, 30 students actually got admitted. 30 means it is in between 20 and 40. So somewhere here, just draw a perpendicular line from this 30 point. So your height of second bar graph, rectangular bar is up to 30. So in this particular 2006 and 7, so you should make that particular point in the middle and you should draw a rectangle. So this rectangle bar should have height which is equal to 30 units, because here I have given 30 as a number. Here I have given 20 and 40. So in between 20 and 40 it will be 30. So that particular rectangular bar graph will be having height till that 30. Similarly, on 2007 and 2008, number of students who got admitted to this particular school is 50. That is actually in between 40 and 60. So from this 50 you can draw a perpendicular line, and the height of this particular third rectangular bar should be ranging till this particular point like this. So this is actually the bar graph where you are actually taking the height of rectangular bars as your expression of data which are there on a particular y-axis. So now on x-axis we have taken one data set, and on y-axis we have taken another data set, and we have actually represented that particular data set which is there on y-axis by varying the height of rectangular bars which we are actually taking on x-axis. This is actually bar graph. So here you can see this particular rectangular bar has very less height. That shows number of students got admitted in 2005 and 6 is less. Similarly, this particular third rectangular box or the third rectangular bar which you are seeing is actually maximum compared to other two. That shows in the year 2007 and 8 there were maximum number of students got admitted to this particular school when you compare with these three data sets. So that means you are comparing between 2005 6, 2006 7, 2007 and 8. So in these particular academic years you are actually comparing, where the minimum rectangular bar is showing the minimum intake of students, so the minimum admission which has happened in that particular school. So the maximum heighted rectangular bar represent the maximum number of students got admitted to that particular school. So this is how you should actually extract information from a graph. So this is how you should actually draw a bar graph. Similarly, you have another kind of graph which is similar to bar graph, which is known as double bar graph. So what you mean by double bar graph is that, so let's say I have three data sets, and how can I actually represent in a two-dimensional graph? So for example, in a graph we have one x-axis and we have one y-axis, but you can only fit one data set on y-axis and one data set on x-axis. So what if I have three data sets? So at that time I should go for another axis, but that is not actually possible in a two-dimensional surface. So on a two-dimensional graph, because x and y are lying on your paper piece, which is actually two-dimensional, only length and breadth is there. That shows you have x and y axis, and on that x and y axis itself you should actually represent three data sets. So how we will do? At that particular point you can go for double bar graph. So let us take an example which has three data sets to be expressed on a bar graph. So there we have marks obtained by student. So here let's say marks obtained by student in a particular subject in a particular academic year. So now we have three data sets which we should actually express on a graph. So let's say there is a student who has got marks in a particular subject in a particular academic year. So let's say we have two academic years like 2004 and 2004 to 5 and 2005 to 2006. So now here you have three data sets. One is academic year, the other is subjects, and the other is marks obtained by that particular student. So in 2004 to 2005, in that particular academic year, in science subject, this particular student actually obtained 30 marks out of 100. Similarly, in the same 2004 and 5, in maths subject, this particular student obtained, let's say, 50 marks. So in 2004 and 2005, the same student obtained in English subject, let's say 70 marks. So in this particular academic year, this is the mark sheet of a particular student where he got 30 in science, 50 in maths, 70 in English. Similarly, coming to the next academic year, that is 2005 to 2006, so there also he had three different subjects, science, maths and English. So here he actually got 40 out of 100 in science subject, he got 30 out of 100 in mathematics, and he got 80 out of 70 in English. So here you can see in 2004 and 2004 to 5 and 2005 to 6, this particular student has acquired a particular marks in a particular subject. So here you have three data sets. One is academic year, the other is subject, and the other is marks which is obtained by that particular student. So now how will you actually fit this in a graph, in a two-dimensional graph? So let's say I have x-axis and y-axis. So this horizontal axis is x-axis and this vertical axis is y-axis. So here marks I have taken on y-axis and subject I have taken on x-axis. So where will you fit this particular year? So how can you fit this particular year? In previous example, you actually drew this particular bar graph which contained only one bar which was expressing one particular data, that is number of students getting passed in a particular academic year or number of students who got admitted in a school in a particular academic year. So here you have two more data sets which you should actually express in this particular graph, that is two academic years. One is 2004 to 5 and the other is 2005 to 6. At this particular point you can actually take two particular bar graphs on a same point on x-axis. So let's say this particular rectangle represent 2004 to 2005 academic year, and this particular shaded rectangle will actually represent 2005 to 2006 academic year. So let's take subjects on x-axis. So one is science subject, the other is maths subject, and the other is English subject. So we have three subjects on x-axis and we have to scale the y-axis. So on y-axis we have 30, 50, 70, we have in the second academic year 40, 30, 80. So by looking at all these data points, we are actually noticing that this particular 80 is the maximum data point and this particular 30 is minimum data point. So on y-axis, you should actually scale in such a way that that particular scaling should contain both 30 and 80, so that in between all other data points will be available. So now I will scale in the same fashion, like 20, 40, 60, 80. So in this particular scaling, I have considered from 0 till 80 and 1 unit I have assigned as 20 marks. So now on this particular point on x-axis, you can actually draw a bar graph. So how much this particular student has got in science? He has got 30 marks in this particular academic year. So for this particular academic year, you should actually use this kind of bar graph. For 2005 and 6, you are actually using shaded bar graph. So unshaded bar graph I am actually drawing on this particular science subject. So the height of this particular rectangular bar is actually equal to this 20, because that particular student has got 30 marks in that particular science subject. So the height of this particular rectangle bar should be up to 30. So 30 is actually in between 20 and 40. So if you draw imaginary perpendicular line from this 30, you will actually get this particular line. So that will be the height of your first rectangular bar. So let's say this is actually one particular rectangular bar which is unshaded, which will actually represent the 2004 to 2005 academic year. Similarly, for 2005 to 2006 academic year, you can use shaded bar, like shaded rectangular bar. So what was his marks in 2005 to 2006 in science subject? So that is actually 40. So now you can draw on the same science point which you actually taken on x-axis, and you can draw a perpendicular line from this 40, an imaginary line like this. So the height of your second rectangular bar graph should be up to 40, and that should be shaded, because shaded box will actually represent 2005 to 2006 academic year. Unshaded box is actually representing the 2004 to 2005 academic year. Similarly, in math subject, he got 50. So 50 is in between 60 and 40. So let's say this will be the point. So maximum this particular rectangular bar can go up to 50 for this particular math subject in 2004 to 5. So for 2005 to 6, he got only 30. So that shows somewhere here. So this particular line. So the height of the unshaded bar graph will be this much only, which is actually equal to 30 units. So because he got only 30 marks in that particular math subject in 2005 and 2006. So coming to English subject, he has got 70 in 2004 and 5, and he has got 80 in 2005 and 6. So that means 70 means it comes in between 60 and 80. So up to this particular point, you will actually draw unshaded bar graph, and up to this 80 point you will actually write shaded rectangular bar like this. So here you can actually clearly notice that this particular student has made improvement in science. So the height of the shaded rectangular bar is more compared to unshaded rectangular bar in science subject. That shows this particular student has actually improved in science subject, and same with the case with English subject. Coming to math subject, this particular student, there is a decrement in his marks in mathematics compared to his previous academic year. So in previous academic year, he got like 50 out of 100, and this particular academic year he just got 30 out of 100. So that shows decrement. So just by seeing this particular double bar graph, you can easily notice how comparison is made between 2004-5 academic year to 2005 and 6 academic year. So like this, you can actually compare three datas in a single two-dimensional graph. So these two bars are actually expressing one data set, that is academic year, that is 2004-5 and 2005-6, and x-axis is representing one data set and y-axis is representing other data set. Like this, if you have multiple points, you can draw multiple bar graphs. Like on the same point on x-axis, you can actually draw multiple rectangular bars, and you can actually have a comparison between those bar graphs. So where you can actually easily compare how much improvement or decrement has happened in that particular area or in that particular data points. So this is how you should actually use multiple bars in a same data set so that you can actually fit multiple data sets in a single graph. So this is actually the advantage of double bar graph or multiple bar graphs. So coming to the next kind of representation of data, there is pie chart in this particular chapter. So you should actually learn how pie chart works. So you should always remember the total angle of a circle is actually 360 degrees. So starting from this particular point, so let's say this is center of point, you should draw a radius from this particular center of point like this. So from here, if you actually make one particular rotation on this particular circle, you are actually covering 360 degree. So that means in a circular graph, if you are representing datas, then that should be actually divided by 360 degree, because in a circle, if you make one rotation, you will be completing 360 degree. So this 360 degree is the standard term which you should actually divide into multiple things so that you can actually fit a particular data in that particular circular shaped graphs. So for example, percentage of number of students, and there is different flavors. So for example, I have different flavors of ice cream and there are certain number of students. I'll just mention the percentage of those number of students. So first flavor is vanilla and the second flavor is actually chocolate and the third flavor is pista. So 50% of students will be liking chocolate flavored ice cream and 30% of the students will be liking vanilla flavored ice creams, and let's say 20% of students are liking pista. So now we have 30%, 40%, 20%. So how we will actually represent this particular data set and this particular data set? Now you have two data sets. One is flavor, like which flavored ice creams you have, and the other is number of students who are there, like the percentage of number of students. So now I will actually divide this particular circle into three zones which will actually represent three different flavors, like how many number of students are liking chocolate, how many number of students are liking vanilla, and how many number of students are liking pista. So here 360 degree is the standard term, because when you cover the entire circle, you will actually covering 360 degree. So here 50% of that particular circle should be chocolate. So I'll just multiply this with 50%. So 50% means that is actually equal to 50 by 100. So 50 by 100. So that shows 0 gets cancelled, 5 ones are 5 twos are. So 2 ones are 2. If you divide 360 by 2, you'll get 180. So 180 degree in a circle actually represents chocolate flavored loving people. So you should actually note the center point of this particular circle and you should actually draw a radius. So from here, you should actually keep a protractor on this particular center point of this particular circle and you should note 180 degree on this particular circle. So 180 degree will come somewhere here. So if you cover this much amount of distance on circle, that will be actually 180 degree. That is the 50% of that particular circle, because here 50% people are actually like 50% of students are liking chocolate flavored ice cream. So you should actually draw a line from this particular point to this center point. So this particular column which you have got in on this particular circle will represent 50% chocolate loving students. So from here you should keep protractor on this particular point and on this particular line. So the second line which you have drawn, you should keep protractor like that on that particular line and you should actually note how much degree will be covering 30%. So for that again you should do 360 degree into 30%. So 30% is 30 by 100. So here 0 gets cancelled, here also 0 and 0 gets cancelled. So 36 into 3. So 36 into 3 will be 108. So 108 degree. So from here you should actually measure 108 degree. So that will come somewhere here. So at this particular point, so draw a straight line from this particular point. So this portion actually represents, so this particular portion will actually represent 30% of the circle. So that 30% will account for 30% vanilla loving students. Next, the third column is actually 20%. So if you measure this particular angle by keeping protractor on this particular line, you will exactly get 20% is actually remaining. So that is actually 360 degree into 20%. So 20% is 20 by 100. So 0, 0, 0, 0 gets cancelled. So 36 into 2 is actually 72 degree. So here you can clearly see 72 degree will be remaining, because 360 degree will complete one particular circle. So remaining is 72 degree, that is actually 20%. So the remaining is 20% of Pista liking students. So this is how you should actually draw a pie chart, where you are actually taking this particular data sets and you are actually multiplying that with 360 degree and getting how much amount of degrees you have to mention on that particular circle. So that particular portion will represent that particular data. So here this first portion which is actually there on this particular pie chart is representing 50% of this particular circle, that is actually chocolate loving students. So similarly 30% of students are loving vanilla flavored ice cream. So that much amount of that portion of circle, so here you can clearly see this particular portion which is there, which is actually representing vanilla loving students, and this particular portion of circle is actually representing pista loving students, and this particular portion is actually showing you the chocolate loving people. So this is how you should actually represent a data on pie chart. So now we have understood pictograph, bar graph, double bar graph, and also pie chart. So based on this particular understanding, we have exercise 4.1 which is there in this particular chapter. So we'll actually solve this particular exercise 4.1. So coming to the first question, they have made a survey among young people in a city, and they have found out that in this particular pictograph they have given 40% of young people love light music, 20% of young people will actually like classical, semi-classical music. So 10% of youngsters will actually like classical music, and 30% of youngsters are actually liking folk music. So here, based on this particular data, they have given three different questions in this particular first question, which you should actually find out answers for. In this first question, they have actually mentioned 20 people are loving classical music. So how many young people were surveyed in this particular survey? So 20 people are actually loving classical music. So 10% is actually this particular 20, because 10% of total population will be actually equal to 20. That is what they are actually trying to tell in this particular first question. So 20 people are liking classical music means that is actually 10%. We know that total number of people will be in the denominator and classical music loving people will be there on numerator. So that many numbers will be there on numerator. So when you multiply that with 100, you are actually getting 10%. So that means here 20 people are actually liking classical music. We don't know what is the total number of people. So that we have to find. So into 100 is actually 10%. So here 20 divided by t into 100 is actually equal to 10. So now you can easily calculate this by shifting this t to right hand side. So divided by t will be equal to into t. So this t is actually total number of people who are involved in this survey. So which we have to find. So total number of people, young people who are involved in this particular survey. So that we have to find. So when you bring the t into RHS, it will become into t. So 10 into t. So here it is 20 into 100. Bring this 10 to LHS. So that will go to denominator. So 20 into 100 divided by 10. So 0, 0 gets cancelled. 2 into 10 will be 200. So total number of people who are there in this particular survey is 200. So out of 200, 20 people are liking classical music. So you can cross verify. 20 by 200 is actually equal to 1 by 10. So that means 10% people are there in this particular classical music liking section. So this is actually cross verification which I have done. So you can actually do in this particular method, and you can actually find out the total number of people who are involved in this survey. So this is the answer for first question in the first question. So moving on to the second question in this particular same first question, we have to use the same data which is actually given here. So the second question which is there in this particular first question is, which type of music is liked by maximum number of people? Here you can clearly see 40% of people are liking light music. So this is actually maximum in this particular given data. So that shows light music is actually liked by maximum number of people. This is actually answer for second question. Moving to the third question in this particular first question, they have asked, if a cassette company were to make 100 CDs, how many of each type would they make? So here, if a CD company is actually manufacturing 1000 CDs, then how they will actually calculate among this 1000 so that they can actually fill out this particular different musics on this particular 1000 CDs. So easily you can actually multiply this percentages which is given. So 1000 into 40, this is total number of CDs into 40%. So that means 1000 into 40 by 100. So that shows 0, 0, 0, 0 gets cancelled. So 4 into 100 will be 400. So out of this 1000 CDs, 400 CDs should be of light music. Similarly, 20% of these CDs should be semi-classical music, 10% should be classical, and 30% should be folk. This you should actually multiply with 1000. So you will get the answer for this. So this you should multiply with 1000, 1000, 1000. So you can do it into 20% into 1000 is actually 20 by 100 into 1000, 10 by 100 into 1000, 30 by 100 into 1000. So when you do that, you will actually get 200 CDs, here 100 CDs, here you will get 300 CDs. So 200 CDs they have to manufacture for semi-classical music, 100 CDs they have to manufacture for classical music, and 300 CDs they have to manufacture for folk music. So like this only a CD company should manufacture. Then only all CDs can be sold for a particular group of people who are actually liking those particular music. So in a group of 360 people, so there were 360 people. So in this particular group they have made a vote. So out of this 360 people they have to vote for their favorite seasons. So 90 people among 360 people voted for summer season, 120 people voted for rainy season, 150 people actually voted for winter season. So among these 360 people, like this, they have actually voted for different seasons, like which seasons they are actually liking the most. So based on this particular data, they have given 3 questions in this particular second question. So you should actually answer for those 3 questions. So coming to the first question in this particular second question, they have actually asked which season got the most votes. So which season is actually liked by most people. So here you can easily see winter season has got 150 votes. Compared to 120 and 90, 150 is more. So that shows more number of people are actually loving winter season, are actually liking winter season. So that means more votes are there for winter season. So coming to the second question, so find the central angle of each sector. So if you draw this particular data on a pie chart, so how much angle will be shared by this particular data among 360 degree? Because in a circle you have 360 degree. So how much amount of angle will be shared by each set of this? So summer is 90. So you should actually divide 90 by 360 because total number of people is 360 into 360 degree. Because 360 degree is the total number of 360 degree is the total angle of a particular circle, and this 360 is actually total number of people, and this 90 is actually for summer. So now here 360 gets cancelled and 90 will be remained for summer. So answer for this second question will be, for summer you should actually allot 90 degree in that particular circle. Similarly, for rainy season, you should actually allot 120 degree, and for winter season, you should actually allot 150 degree. Because 120 by 360 into 360 will be 120. 150 by 360 into 360 will be 150. So summer season will get 90 degree, rainy season will get 120 degree, winter season will get 150 degree on pie chart. So coming to the third question in this particular second question itself. So in that they are actually asking, draw a pie chart to show this information. So you can easily draw a pie chart. So draw a circle like this. Actually note this particular center point and draw a radius from this particular center point. So keep protractor on this and calculate the first degree. So for summer you have 90 degree. So calculate 90 degrees. So 90 degree will be somewhere here. So draw a straight line from this 90 degree to this center point. So this is actually 90 degree, which actually represent summer. Similarly, keep protractor on this particular point, and from this particular line you actually measure the next angle, that is actually for rainy season, that is 120 degree. So 120 degree will be somewhere around here. So this is actually 120 degree. So this 120 degree will represent rainy season. Similarly, the remaining part will actually account for this 150 degree. So this is actually 150 degree, which accounts for winter season. So like this you can easily draw a pie chart. So always drawing pie chart, you should actually have a compass with which you can actually draw a circle, and you should use protractor, and you should actually note the exact degrees, and you should actually draw straight lines from that particular points. So initially for summer 90 degree was here, so from there I have actually drawn a line for the center point. So this particular first portion will represent summer, and this particular second portion is 120 degree, and the remaining is 150 degree. So here 120 represents rainy and 150 represents winter. So this is how you should actually draw a pie chart. Similarly, coming to the third question in this particular exercise, blue color is actually liked by 18 people, green color is actually liked by 9 people, red color is actually liked by 6 people, and yellow color is actually liked by 3 people, and total is 36. So now to calculate this particular 18 in a pie chart, you should actually do it like this. So 18 by 36. So this 36 is actually the total number of people into 360 degree. So 36 ones are 36, tens are 360. So 10 into 18 will be 180. So 180 degree will actually represent people liking blue color on pie chart. Similarly, 9 divided by 36 into 360 degree. So 9 divided by 36 into 360 degree will give you 90 degree. Similarly, you will get 60 degree for red, and for yellow you will get 30 degree. So you should actually draw a pie chart like circle like this. You should note the center point, and you should actually draw a line, and you should calculate 180 degree from this center point, keeping on this particular line using a protractor, and you should calculate 180 degree. So this is actually 180 degree. So this 180 degree will represent blue color preferring people, and green color 9 people will be preferring out of 36. So that will be actually 90 degree. So 90 degree. So this is actually 90 degree. So you should keep protractor on this particular line and measure 90 degree and draw a line from like this. And this particular section will be green color. That means 9 people are actually liking green color. Similarly, 60 degree. From here you can draw 60 degree, and this is 60 degree, and the remaining will be 30 degree. So 60 degree section will be for red color, and 30 degree section will be for yellow color. Like that means that colors are preferred by that particular group. So like this you can neatly draw this particular pie charts, and I have also explained how to draw a pie chart and how to calculate the degrees which you should give for a particular data point in that particular pie chart. So using all this information, you can actually neatly draw a pie chart. So this is actually the part 1 video of data handling. Similarly, regarding probability, which is there in this particular chapter, I'll do part 2 video. So if you refer both part 1 and part 2 video of this particular data handling, you can understand this 4th chapter which is there in this 8th standard mathematics. So like this, I will be uploading more and more physics, chemistry, mathematics related topics in this particular YouTube channel. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.